Okay, so I'm gonna talk about some things in the textbook today for some examples. So you don't have to write this down. You only have to write down what I write down, and I'm gonna not write things down until example number 3. So basically, what we're going to talk about in this section is classifying a solid, describing what the cross sections of the solid are, and then we're going to sketch and describe solids of a revolution. So this is the main thing. That's what's going to be in the homework. Is that last one is describing a solid of a revolution. But the first thing I want to do is classify a couple terms, and this is why I'm going to the textbook, because this looks a lot better than my drawing. A vertex is a corner, but on a three-dimensional object, it's the corner of where everything meets. So we're used to a vertex being where two things form an angle, or a corner is usually what we call it, but you can have corners on three-dimensional objects. The flat surface on a polyhedron is just like, it's a two-dimensional plane, usually rectangular in shape, or it'll have some sort of shape, but we just call that a face. And then lastly, an edge is just like the line. So the vertex is like a corner, but the edge is like a corner that's in the shape of a line segment. Okay, so to be formal, this is a vertex, this is the edge, and this is the face. So a polyhedron is just this. It's like a prism. And then you have non-polyhedrons, which usually have some sort of circle. So a cylinder or a cone, that's a polyhedron. You can have a pyramid that has a polygon base but meets to one vertex at the top. And then a sphere is like a circle of circles. Okay. So now what I want to show you guys is example number 1, and we're just going to read it and talk through it. Like I said, you don't have to write anything down until example 3. So here we have 3 figures that are drawn, A, B, and C, and it says tell whether it is a polyhedron. If not, name the polyhedron. So the first one is definitely a polyhedron. It's a prism. It has rectangle faces. The next one is a pyramid. It has a polygon for the base, and it meets to a single point. And the last one is a cone because it has a circle for the base, and then it meets at a point. And so that's just basically it for that. Now for the next page, we're going to talk about describing cross sections of different three-dimensional objects. So when you take a plane, and a plane is like two-dimensional, in other words, this little thing that looks like a piece of paper and it's slicing into the square or slicing into a cube, that cross section, that slice that we take out of the 3D shape, this is a big cube in blue, but we could take a slice out of it, it forms a square. But now if we put our slice at an angle, it creates an elongated rectangular shape, so that's what we call a rectangle. And then if we slice the corner of a cube, it forms a triangle. So for example number 2, it says describe the cross section. So here we have a polygon base and a polygon base and rectangular faces. So this is what we would call a prism, but if you take a slice right down the middle of it, that would be a hexagon. And then for part B, if we take the slice out of a triangular pyramid, then it would be a triangle. For part C, if we take a slice out of a cylinder, that would be a rectangle, just because of the angle that we're doing it at. Now, this is what we call a conic section. If I slice parallel to the base, then that would be a circle. And then D, if I slice through a sphere at any angle, it's going to create a circle. Sometimes you can get an ellipse. I got to think that through. Yeah, you got to slice through. No, not on a sphere. I think it's this. I got to think that one through. I think an ellipse comes from a cone, not a sphere. So a sphere will always be a circle. And then F, if I slice out a corner of a cube, then that could be a trapezoid because of the way the shape is. And so that's basically it with regards to three-dimensional figures. Now the reason we're prefacing all this stuff and labeling the terms and stuff is because in the next section we're going to start to do volume. And you need to kind of know the words and the vocabulary and where the shapes come from, right? So we live in a three-dimensional world, And so we identify different sections of three-dimensional shapes as squares, circles, rectangles, and stuff like that. One of the things that's very helpful, but it's also kind of challenging, is knowing about revolutions and creating shapes from revolution. So I'm just going to dive into example number 3. And this is kind of an abstract idea. Let me zoom out so you guys can see the whole thing. If I have a rectangle, where this is 4 and this is 4, this is 9 and this is 9, and I rotate that about this axis 360 degrees, what shape will it make? Well, if I rotate that around, it's going to make a cylinder. But the thing about the cylinder is that I'm rotating it about this axis, so the radius of the cylinder is 4 and the length is 9. Okay? So if I were to turn that another way, in other words, I could say that the radius is equal to 4, and this would be the height of the cylinder. So if I turn this sideways like this, we would consider that the height of the cylinder. So we would say the height is equal to 9. We're not going to calculate the volume today, but that's just, you know, if you, this is very helpful in calculus. These revolutions. This helps engineers too, because I could take a simple item like this, which is a rectangle, find the area of the rectangle, and then do some fancy math, and then find the volume of a cylinder. That's where all those formulas come from. So that's just one example, example number 3. And then, so that's part A. And then part B is if I have a triangle, and I have a base of 2, and it's a right triangle, and the height of 5, and I rotate that 360 degrees, what would that shape be? Well, that would just be a cone, a perfectly drawn cone. Boy, that is way off. Who still has a height of 5 and a radius of 2. And so that would basically be it. And so in your assignment today, you're gonna be given some information. You're gonna have to determine what shape it makes and what are the dimensions of the shape. And then, like I said, in our next assignment, what we will do is we will look at that and figure out how to figure out the volume of a cone, and how do you figure out the volume of a cylinder, and how do you figure out the volume of a cube or a rectangular prism. Okay?